Hi, this is Sean Mullery from Electronic Engineering at IT Sligo, and what I'm going to cover in this lesson is a little bit more on the linked list, specifically some of the functions, and I'm going to look in this lecture specifically at the insert function, and then in the next lecture I'll look at the delete function so that we see them all separately. So just to mention, I mentioned in the last lecture that I wasn't entirely certain why in some of the functions Dytel had put in an asterisk here, and in others they hadn't. Now there is a specific difference, and it's that if we look here at the typedef list node for list node pointer, it's already a pointer. And so it seems a bit strange to put another pointer onto it. That suggests it's a pointer to a pointer. And in fact, that's what it is. And the point here is that for the insert and the delete functions, we actually want to make a modification, or there is a possibility of making a modification to that element or that pointer. Whereas for the empty and the print list, all we want to do is to use that pointer and move on. So we don't want to make a modification to it. And it's all to do with the very start pointer is literally just a pointer to one of the list nodes, and in fact it's a pointer to the list node. So it's literally just an address that we want, because we don't want to actually send the item. We don't actually have the item yet. So in the very first case inside main, when we make this start PTR here, the point is that that's just an address of one of those structs. There's no actual struct associated with it, and therefore we would have to make that later on. So that's why we send the address of it as opposed to it itself, because it itself doesn't yet exist. Okay, I don't want to go into too much more detail. The pointers to pointers can be quite a complex thing to understand, and I'm a little bit more concerned about you understanding the linked list at the moment. So what I'm going to do is I'm going to move down to the insert function here, and we're going to take a look at that. So as I said, we send in a pointer to the start of the list, and we also send in the value that we want to insert into the list. And what we do is we create a number of pointers in here. What we do is we create a new PTR, and that's basically for our new data. So we're going to create a new struct. We're going to insert that value into it, and then we're going to try and put that node that holds that data into our list. So that's covered by new pointer. That's what's pointed to that. What we also want is we want a system whereby we can go down the list, and we do that by going having the current pointer, which is what link in the list are we at the moment, and also what was the previous link. We need a link, we need a pointer back to that, so that if we have to insert something in the list, we now have the current thing we're pointed to, we have the previous thing we were pointed to, and we have our new pointer, and we're going to be able to use the three of those together in order to get our new item into the list. So that's why we have the three of those. So the first things first, we need to actually create the memory space to hold the data that's going to be in our new node or our new link within the list. So we do that with the malloc function, and we send it the size of a list node so that it knows to give us the correct number of bytes that we need in order to complete that node. And it sends us back the memory location of that is created, and we assign that to new pointer, so that our new pointer now, which as I said is a list node pointer, that now points to the new piece of data that we've just created, or the new link. So you can imagine you've got a chain or a set of links together. So you've just created a new link, and you're now going to put some information into that, and then you're going to put it into the entire chain somewhere in the middle. Okay, so that's the information, and we haven't actually put the data into it. So the next thing that we're going to do is we check here to see what happened with the malloc function. Firstly, was it able to give us the memory that we wanted? If it was, then this line here, line 85, is true. New pointer is not equal to null, therefore we're clear to go ahead. But just on the off chance that it is equal to null and we couldn't for some reason have the memory, you can see down here there's an else to deal with that at line 106 and 107. Printf, that particular character was not inserted as there was no memory available. Okay, but let's assume that it has gone in okay. What we now want to do is we want to put the actual data into that memory So we've created the new link, we want to put the data into it, so we say new pointer's item data, we set that to value. So value come into the function here, so that's the character we want to insert, and that goes into the data element of the new node on the linked list. And if we just go back up the top here, remember that new pointer is pointed to one of these structs here, these list node structs, and it has an item called data. So we're just filling in the information on that data. Now, what we do is, now that we've filled in the information on it, if you remember, and I'll just pop back up to it again, each one of these nodes has a pointer to the next node. Now, we don't know yet where we want to insert it in the chain or in the linked list. So for the moment, we're just going to set this to null, that it's not pointing anywhere. Otherwise, it could cause trouble. So we'll just set that to pointing nowhere by setting it to null. Now what we're going to do is we're going to go down and search through the list and find where we should put this node. So we're going to start at the top of the list, at the start of the list, and we're going to go down element by element through it until we find an appropriate place to insert our value. And remember, the appropriate place to insert our value is when the value is a smaller number than the next value in the list. Okay, so if it's a smaller number, remember these are in ASCII characters, so therefore a capital A would be a smaller number than a capital B. I think they're 65 and 66, something like that in the ASCII character set, and therefore as soon as we find that it's a smaller value than the next value in the list, that's where we want to insert it. But we want to make sure that the item before it is of a smaller value again. Okay, so that's what we're going to do here. So to do this, we have two pointers. We want to point to the current place we are in the list, but we also want to keep a memory of where we were last in the list so that we're then able to link them all up. Because if we find that the current value that we need to insert it in front of it, we need to have the previous value, or we need to have the previous link so that we can link from that to our new pointer and from our new pointer to the next value in the list. So what I do is I set the current pointer, or the one we're looking at the moment, I set that to the start. There is no previous pointer yet because we haven't got moving down the list, so we set it to null. Now what we do is we have a while loop, and the while loop basically moves through the list until it comes to a point where it's ready to insert the value. And that could happen for either of two reasons. Either we've reached the end of the list and not found any situation in which our current value was smaller than the value in the list, which means that it's obviously a capital Z or a lowercase z or something towards the end of the list. In other words, it's going to be at the end of the alphabetical order, and therefore it needs to be inserted at the end of the list. Or, on the other hand, we would stop if we suddenly found that the value was no longer bigger than one of the elements in the list, and that means that we've now found a value that we should insert before that value. So we keep going until one of these is dissatisfied. Either it's found its way to the end, or it's found a value that's bigger than it. And what we do is we basically transfer the thing along. So we move along the link by doing the following. We take the current pointer, so the pointer to the current link in the chain, and we give that to previous pointer. So previous pointer now points to the current pointer, and we now point the current pointer to its next pointer, so that it moves along the list, so that we now have previous and current at different values again. And that continues to happen as we move to the next point and the situation isn't satisfied. Again, we put the previous pointer pointed to the current pointer, and we move the current pointer on one more spot. And we keep doing this until we either find that we're at the end of the list by this thing, or we find a situation where value is now smaller than the current pointer, which would stop our while loop. Sorry, I shouldn't have deleted there. Now, why did the while loop end? Did it end because we reached the end of the list, as is the first situation here, or did it end because we found a value that was smaller than the current value? Well, we know that it happened because of, the first thing we need to check is, what is the value of previous pointer? Because in the very first case, it was null. So if we entered the string, if we entered the list and we found that there were no items in the list, okay, that's the situation we end up with if previous pointer has not at any point been progressed on. Okay, so in other words, on the very first occasion we found that we were at the null pointer straight away, it meant the list was empty. So this, in effect, this if statement here is if the list was empty, this is the first item in the list. If that's the case, what we do is the new pointer's next pointer, which previously we just gave a value of null because we weren't sure where to put it. What we do is we point it to the start of the list. Okay, and we also point the start of the list to new pointer. Now this seems a little bit strange, but what we're effectively doing here is just basically sitting it into the system that there's nothing else within the list. So maybe just to talk us through this one again, because I'm struggling to explain it perfectly. We currently have an address, as I said, that's the beginning of the list. So we put that into the next pointer, okay, so that we're now pointing to that. So we're inserting at the beginning of the list, and then we update the start of the list to be the new pointer. So what we're doing in here, in effect, is we are changing these values. What we were pointed to originally is now the next pointer, so we've inserted ahead of the start of the list, and we've now changed the start of the list to be our new pointer. Okay, so this is effectively pushing us to the very front of the list. Okay, that's the situation if we were the very first item in the list. What happens if we are not the first item in the list, there's already items in there? Well, what we do at that point is that, and remember that we move down along the list until the current pointer was a value that we want to insert in front of. Okay, so the current pointer is pointing at a link that's where we're going to make the break, or we're going to make the break in front of that. So what we do is we take the previous pointer's next pointer. Okay, and remember the previous pointer was pointed to our current pointer. Or its next pointer was pointed to our current pointer. We now want that pointed to our new pointer. So this is effectively now linking our new link into the list. And then from our new link, we then make its next pointer. So that's new pointer's next pointer. We point that to the current pointer that we had, that we were pointing at. And that has now inserted the link into the list. So that's what happens if that's the case. And this will happen even if the current pointer is null. All that happens is that the current pointer will be a value of null, and that will go into that next pointer, and it'll insert us at the end of the list. Okay, so that's the insert function, and what I'll do in the next recording is the delete function.